Hello everyone, and welcome to Geospatial Onboarding for Data Carpentry Instructors. My name is Erin Becker, and I'm the Associate Director with the Carpentries. I will be leading the onboarding session today. This onboarding is primarily intended for people who are already certified Carpentries instructors. Additionally, trainees who have completed the 2-day instructor training course and are now working towards their certification, or applicants who have applied to take part in instructor training and are waiting to be notified of their involvement in the course. Please do note that this 1-hour onboarding session is not a substitute for the 2-day instructor training course or for any stage of the instructor checkout process. If you're not a certified instructor, you will need to complete instructor training and the checkout stop stages before teaching at a centrally organized carpentry workshop. Please do check out the links on the slides for more information about instructor training and the steps involved. If you're not already a carpentry instructor, please do continue with the onboarding. We are interested in getting these lessons out to as broad of a community as possible. Additionally, if you are not a certified instructor, you are welcome to use and adapt these lessons for other teaching contexts, along with any other data carpentry or software carpentry lesson. Please do see our license for usage conditions. If you are not a certified carpentry instructor, you can teach alongside a certified instructor at a self-organized carpentry branded workshop. There are some requirements in order for a workshop to be labeled with the Carpentry's brand, so please do see those requirements with the link on the slide. If you're already listening to this onboarding, you probably already have some idea of what it's intended to convey, but the goals of this onboarding are twofold. One is that it will help prepare you to teach the Data Carpentry Geospatial workshop. Now that workshop is 2 days worth of materials, so we will not be going through all of the content in depth in this 1-hour session. But what we will do is give you an idea of the structure and layout of the curriculum, an understanding of what data types and tools are taught in the workshop, as well as give you an idea of where to go for troubleshooting or for answers to problems that may occur during the workshop. The second purpose of this onboarding is that it will give you priority placement for teaching at geospatial workshops that are centrally organized. So if you are a carpentry instructor and you are signed up for our instructor mailing list, you will get notifications of teaching opportunities. And if you indicate that you have completed this onboarding, you'll be given priority placement at those teaching opportunities. I'd like to start with an overview of the entire workshop. There are 3 lessons included in the workshop. The main lesson is the 3rd lesson, and it's called Introduction to Geospatial Raster and Vector Data in R. There are 2 introductory lessons that are optional and depend on the background of the people who are attending your workshop. For people who have no or little prior geospatial background, but will be working with geospatial data in the near future, the Introduction to Geospatial Concepts lesson is available. And if there are people at your workshop who have little or no experience working with the R programming language, there is an Introduction to R for Geospatial Data lesson as well. That gets people up to speed with the core foundational concepts of using R so that they're able to work with the more specialized geospatial packages that are introduced in the 3rd lesson. The overall goals for the workshop are that by the end of the 2-day workshop, your learners should be able to import and export spatial data in specific formats into and out of R. They should be able to access and understand the metadata associated with those file formats. They will spend quite a lot of time creating multi-layered and customized plots using a combination of different raster and vector data sets. They'll also be able to plot and perform calculations using single and multi-band raster data and also will know how to work with data in different projections and reproject that data as needed. The overall structure of the workshop, I mentioned that there are 3 lessons. The first 2 are optional introductory lessons that are recommended if you have learners who meet particular profiles. If you have groups who have little or no experience with geospatial data, the Introduction to Geospatial Concepts lesson is about 75 minutes to an hour and a half, and that we'll be talking about in just a moment here. The second introductory lesson is approximately 4 hours and is very important if you have learners who aren't familiar with R to get them up to speed on R syntax and plotting and all of the things that they will need to be using in the more advanced third lesson. This third lesson is the meat of the workshop and is approximately 7 hours long. I say approximately because the time for all 3 of these lessons is very much an estimate, and we are relying on people who teach pilot workshops for these lessons to give us more information so that we can accurately estimate the time that will be involved in teaching them in different contexts. We've gotten the question often about if you have learners who have a background working with GIS and who have some experience with R, if it's possible to teach a 1-day workshop using only the 3rd lesson and assume that people have the information that they would have learned in the first 2 lessons. It's theoretically possible, but we do not recommend it because we find that often audiences, the learners and the instructors will tend to overestimate the experience level of the learners, and learners will also tend to overestimate their own experience level. Also, 7 hours of content is a bit more than we would fit into a single day, including lunch breaks and coffee breaks, and it's always good to have a little bit of extra time to work through the challenge problems and have a good discussion. So we do recommend setting aside 2 days for the workshop, even if you have a little bit more GIS and R-oriented group of learners, to give yourself time to make sure that the learning experience is very positive and effective. We'll now talk about each of the 3 lessons in a little bit more detail, starting with the Introduction to Geospatial Concepts lesson. This lesson introduces learners to the fundamental attributes of raster and vector data types. It introduces learners to the types of data that are commonly stored in raster or vector format, as well as distinguishing between categorical and continuous raster data and introducing the idea of multi-layer rasters. It also gives a very superficial introduction to the file types and R packages that learners will be using in the rest of the workshop, simply to start to introduce that terminology. It introduces coordinate reference systems with a particular focus on the Proj4 format, which is the format that learners will be working with for the rest of the workshop. And it ends with a section on commonly used programs and applications for working with geospatial data. A couple of points to make about this short lesson. There are many images in the lesson that are used to illustrate concepts such as the structure of a raster data set or the difference between raster and vector data. Those images should be shown to the learners when you are discussing, as they're very spatial concepts. It's also useful to expand on those concepts by drawing on the board to give some more concrete examples of the types of data that are being discussed. These lessons are very lecture heavy, which is uncommon for carpentry workshops, in particular because this is the first lesson of the workshop. Do be sure to include the discussion that are incorporated into the lesson, as well as the challenge questions that are included in the lesson, and provide plenty of time for your learners to ask questions. Don't skip the exercises because those are what provide the interactivity and make this workshop have the feel of a carpentry workshop. And it's important for learners to get that feel and that interactivity from the very beginning of the first day of the workshop. We are very interested in receiving contributions back to the lessons. If there are additional things that you do in your pilot workshop to add an additional activity or discussion into this lesson, please do contribute those back to the lesson. And there will be instructions at the end of this slide deck about how to submit suggestions for improvement. A last point to make about this lesson is that the final section of the lesson, which is called the Geospatial Landscape, does include quite a long list of types of software that are used for GIS applications. Don't read off the list to the learners. There's quite a lot of it and it can get a little overwhelming. Instead, it's better to approach it by asking learners what pieces of software they've used for GIS applications or that other people in their lab have used, and to help them place those pieces of software into the larger framework of whether they're command line interfaces or graphical user interfaces, whether they're commercial, whether they're open source, and help the learners think through the benefits and downsides of those different dimensions of the programmatic landscape. That's all of the discussion that we'll have for that first introductory lesson. Moving into the second lesson, which is Introduction to R for Geospatial Data. This is a shortened version of another carpentry lesson, R for Reproducible Scientific Analysis. That lesson is approximately twice as long as this introductory lesson. And what we've done is retained only the portions of that lesson that are necessary for learners to understand and be able to do before they start working with the tools that are used in the third lesson. So this lesson covers working with R in the RStudio GUI, project management and file organization, how to import data into R with a focus on CSV data, and the learners will work with other types of data imports in the third lesson. It also introduces R's core data types and data structures, including tabular data and manipulation of data frames. There's a very short introduction to visualization, just to provide the basic framework, which will then be expanded on a lot in the third lesson. And this lesson ends with how to write data to a CSV file. Because it is a shortened version of this lesson and has a different audience, it does not cover plot customization. Again, this is covered in much more detail in the third lesson in this series. It also does not cover writing good software, as the assumption is that many of the people in this particular workshop will be learning how to use R packages for the first time and will not quite be at the point of writing their own software at this point. It also removes from the R for Reproducible Scientific Analysis lesson anything that's dependent upon knowledge of the Unix bash shell or version control. These are both tools that are taught in software carpentry lessons, but are not included in this data carpentry geospatial workshop. If you have taught or been involved with the R for Reproducible Scientific Analysis lesson before, there are some specific differences to be aware of between that lesson and this shortened version of it. One is that there are some geospatial specific recommendations around project management in that section of the lesson. Do be sure to include those, as they will be important for your learners working with geospatial data. It does use the Gapminder dataset, which is also used in the R for Reproducible Scientific Analysis lesson, as well as a small dataset about life expectancies in Nordic countries. And a quick note that it is essential to have your learners download this data in the first challenge of this lesson. The last point to make about the differences between this lesson and the other version are that the visualization examples cover geoms that will be used in the third lesson in the series. And those geoms are geohistogram and geocall, rather than the geometries that are introduced in the alternative version of this lesson. Moving into the third lesson in this workshop, the Introduction to Geospatial Raster and Vector Data with R, I want to emphasize again that the timings on the episodes for this lesson are estimates and will very much not be accurate. And we are really depending on pilot workshop instructors to let us know what timings were more accurate for their workshops so that we can update those to give better information. This lesson as a whole uses the Raster, RGDAL, and SF geospatial packages in R, as well as plotting with ggplot2 with the geom-SF and geom-raster supports. A very important point to make about this third lesson is the importance of having your learners download the dataset and install the software before the beginning of the workshop. The dataset that's used in this workshop is quite large, especially compared to other carpentry workshops. It is a little bit over 150 megabytes. And there are numerous different software packages and R libraries that your learners will need to install. People who have taught previous pilot workshops have recommended reminding the learners multiple times before the workshop to download the data and install the software, and to be very upfront about that requirement, but also to keep in mind that you will have some learners who weren't able to complete the software install before the workshop and need some additional support. So to provide some time, usually around half an hour at the beginning of the workshop, to make sure that everyone has everything installed properly. I want to walk you through some of the instructions for data download and software install, so it's clear where those instructions are and where your learners can get access to them. So there's a setup page on the Geospatial Workshop repository that looks like this. I'm going to skip the data section for now and come back to that in just a few minutes and go into the software install section. There are two options for software install. The first here is local installation. This lists each of the pieces of software that your learners are required to install, with links to the installation and manuals for each of those. And then for each of those pieces of software, there is some more information about how to install it on particular platforms for each of the three major operating systems. I will note that I didn't have any of the geospatial software installed prior to working on these lessons and was able to follow these software install instructions. But please do keep in mind that many of your learners may not have experience with software installation and with troubleshooting. So please do make allowances for that and be supportive of learners if they're having difficulties. The second option for software install is using Docker instances. There are some extensive instructions here on how to download and install the Docker images, and that is an option for your learners as well. We do recommend starting with the local installation option, as this gives learners the opportunity to go through the installation process, understand how it works to some extent, and how to troubleshoot it, and gives them a copy of the software on their own machine, rather than having kind of a black box installation that they don't see happening. This gives them more autonomy and independence later on in their lifetime of working with different software packages, so they know the system and the workflow for updating new software, updating their software and installing new software. So we do tend to recommend local installation where possible, but we do also have the Docker system as a backup. Going back to the data set, I want to first introduce the data set at a high level, and then I'll show the data description page. The data that's used in this workshop was collected by the NEON, or National Ecological Observatory Network, which is an NSF-funded research group. The data was collected in two of their many collection sites. One is the Harvard Forest in Massachusetts on the eastern coast of the United States, and the other is the San Joaquin Experimental Range in California on the western coast of the United States. The data that's used in the workshop includes 4 different types of data, including site layout shapefiles for the Harvard Forest field site, meteorological time series data, again for the Harvard Forest field site, LiDAR data on canopy height, elevation, and surface modeling of both of the 2 sites, and then Landsat 7 normalized difference vegetation index imagery, again for both of the sites. And if you look at the data description page, you'll see a much more in-depth description of the different data files, including the file names that are included in the data download. You can find more information about the individual field sites by looking at the NEON field site description pages. This will give you as much information as you could possibly want to know about the data collection types, site characteristics, data collection methods, etc. And you can see those for both of the field sites. There's also more information about how each of these different types of data sets was collected. And this is quite a bit of information. Your learners may not need all of this information, but give them some introduction to the data with a particular focus on the fact that there are 2 different field sites. There will be several different places in the lesson where they have to compare the analysis that they're doing for these 2 different field sites. So it will be important for them to have that clarity. The other thing to remember when your learners are downloading the data, there is a single download link that will allow them to download the 4 zip files that are included in this data set. Your learners may or may not be familiar with compressed data, so they may need a little bit of explanation about how to expand that data to see the individual data files. There is also more information about this data set on Figshare, including its citation for publication. Going back to our slides, now that we've talked about the data and the software for this 3rd lesson, I want to provide some introduction to the common issues that might arise when teaching this workshop. The most important of which is that the episodes within the lesson, the individual segments of the lesson, are laid out in such a way that it assumes that all of the preceding episodes have been taught and that the learners have retained all of the objects that they've created and the libraries that they've loaded in their environment as they've worked through the workshop. So there are two things that you as the instructor can do to help make sure that this is the case. One is to ensure that your learners are working from and saving a script. They will be introduced to the concept of scripts and saving scripts in the introduction to R lesson. So you can help make sure that that is occurring, you and the helpers, by going around the room. Secondly, you can remind your learners to save their workspace when they close RStudio for breaks and the end of day one. When they go to close RStudio, it will give them an option to save the entire workspace, which will then, if they open it back up for the rest of the workshop, will load up their environment with all of the data objects and libraries just as they left it. So those are two proactive things that you can do to help make sure that the workshop flows smoothly for the learners. There will probably be some issues because you will always have some learners who are having more difficulty or falling behind, and that's okay. We still want to support those learners. So there are other things that you can do to help learners catch up if they don't have the correct objects or the correct libraries loaded in their workspace. So what you would do as an instructor is go into the R Markdown file for that episode that you're teaching and take the hidden chunk of code that loads in all of the required data objects and the libraries that are needed for that particular episode. So you can go into the R Markdown, the episodes _R Markdown folder within the GitHub repository, and I'll show you how this is organized. So this is the episodes RMD episodes RMD directory within the R Raster Vector Geospatial GitHub repository. There's one file for each of the 14 episodes in this lesson. I'll choose one that I know has dependencies. So if I open this episode 7, I can see the GitHub rendered version of the R Markdown code. It has this rendered header, and then directly under that there are a few chunks of code. This chunk of code is what loads in all of the libraries, and this chunk of code is what loads in all of the data that the learners need. To get the raw code, you would click this raw button in the upper right-hand corner. That will open the R Markdown file without any formatting. You would then extract, copy, and paste this chunk of code with the libraries and this chunk of code with the data, and copy paste that into the workshop Etherpad so that your learners can copy that into their RStudio script and be instantly caught up with that point in the lesson so that they're able to continue on par with the other learners in the workshop. I'll show a couple more examples of that R Markdown file. So this is for episode 2. These are the libraries that are required for episode 2 and the data that learners will need to load in for episode 2. Again, you will click the raw button to extract those 2 code chunks. Here's the same thing for episode 7. About half of the episodes in this lesson have those dependencies, so this is definitely something to be aware of. Another point to be aware of for this lesson is that there are a few episodes that have figures that are treated as demonstration figures. They have no code shown. Normally in the lesson, the code will be shown and then the figure that's produced from the code. But in certain cases, the authors of the lesson have decided not to teach the code that is used to create a particular demonstration figure. That might be because the code is too complicated for learners at that point, or it uses concepts that haven't yet been taught. So the way to teach these sections are to show the images from the lesson page by projecting it from your screen, but not to go over the code itself. If you as the instructor want to look at the code or make any changes to the code, you can access it through the R Markdown files as described above. And it will have the echo equals false markdown chunk associated with it to keep those code chunks from displaying. Here are two examples of demonstration figures that are shown in the lesson without any code associated with them. And again, you can pull out the code and use it, but do not teach it to the learners. It's a bit too complex for the point in the lesson where it's introduced. A couple of other things to watch out for. One is that many different files have similar file names. They start with the abbreviation for the field site that they're associated with, so either HARV for Harvard Forest or SJER for San Joaquin Experimental Range. Make sure that your learners are familiar with those abbreviations as well as the other abbreviations that are used in the file names. Those are all introduced in the lesson, but be very deliberate about them. And go over what they stand for so that people aren't as confused. I will say that as someone who doesn't have a geospatial background, as I worked through these lessons for the first time, I was a little bit overwhelmed by the number of different files that are presented. And so please be patient with your learners and help them to make sure that they're using the right files for the exercises. And we already talked about the dependencies between episodes, so please do keep that in mind as you're teaching. We're nearing the end of our onboarding session now, and I wanted to end by giving you some pointers on how to prepare to teach this or any other carpentry lesson. The first thing to do is to read the instructor notes for the lessons that you're teaching. Those are linked here as well as from the lessons page. I'll show you a preview of one of these lesson instructor notes for the third lesson. They will always start with some overall comments about the design of the lesson and the overall learning objectives. But the part that I find the most helpful is that for each episode of the lesson, there are some specific points about things to be careful with for that episode, what learners will have seen before, what is new to them, and what you might need to be careful in explaining to avoid confusion. So those exist for most of the episodes in this lesson. We'll see that there are a couple places where we don't yet have any notes on specific points for that episode. Please do consider contributing your own notes to the instructor notes document to help future instructors based on your experiences at your workshops. These notes also explain error messages that your learners may see and how to deal with them, and also provide some technical tips and tricks for making sure that your learners get the most out of the lesson. Those exist for each of the 3 lessons in this workshop, as well as other carpentry lessons. So those are a very good resource to have. The second thing I would do in preparing to teach is to read through the materials that you'll be teaching and test out each line of code on your own machine. If you have worked with these packages or similar R packages a lot, you may not feel that this is necessary, but please, please do test things out on your own machine to make sure everything runs smoothly. Because even a minor change in the environment of your system or the syntax of the code chunk can affect the way that the code behaves on your machine, which will increase cognitive load for the learners if that's not handled up front. So please test out each line of code and make sure that it behaves the way you expect it to behave on your machine. If you have general questions about teaching Carpentry's workshops, please do consider joining an instructor discussion session. You can see the schedule and sign up for those sessions by clicking on the link on the slide. And you can discuss there with other instructors what their strategies are for preparing to teach. Congratulations! Now that you've completed this onboarding session, you now have priority when signing up to teach geospatial workshops. Please make sure that you are on the instructor mailing list so that you hear about upcoming teaching opportunities. Please also send an email to the email that I will display shortly about the fact that you have completed this onboarding so that we can note it in your instructor record. If you don't want to wait for a new teaching opportunity to be announced, you can organize a pilot workshop at your institution. There's some information about how to do that at that link. And we also, as I've mentioned several times, are actively seeking feedback from people who are teaching these workshops to inform the lesson developers and other instructors and help continuously improve the workshop. If you're not sure how to leave that feedback, please look at the instructions that are linked here. We try to be a very welcoming and open community, so please don't feel like any question or comment is stupid, and do feel free to leave comments on the issues and PRs for these repositories. If you have questions or concerns about the lesson, the first place to start is the instructor notes to see if others have had the same problem. You can also contact the DC Geospatial Slack channel with questions about the lessons. There's a link to sign up for the Slack channel there. If you have broader questions or broader discussion points about the lessons, you can send an email to the Geospatial curriculum list for that discussion. And if you have questions about workshops or teaching, or to let us know that you have completed this onboarding, please contact team@carpentrys.org. Again, we do need you to tell us that you've completed this onboarding so that we can make a note in your instructor record so that we can prioritize you for future teaching opportunities. So please contact team@carpentrys.org. Thank you for completing this onboarding, and we hope to see you at Geospatial Carpentry's workshops in the near future.